Welcome to The Explainer. Today, we're diving into the opening of a truly mind-bending sci-fi mystery. I want you to just picture this for a second. Imagine waking up with absolutely zero idea of who you are, where you are, or why you're even there. But deep down, you somehow know that the survival of the entire human race rests squarely on your shoulders. And the only tool you have to figure it all out? The scientific method. It is such a fantastic setup, so get ready because we are going to explore a scenario where survival literally depends on science. Okay, let's jump right in.
Our story kicks off in complete and utter darkness. Our protagonist wakes up blind, paralyzed, and totally helpless. He can't move his hands, he can't wiggle his toes. The only thing he can actually hear is this soft, emotionless, feminine computer voice just relentlessly asking him over and over, what's 2 plus 2? Every single time he tries to speak, to beg to know where he is, or just cry out in pain, he's met with the exact same cold response. Incorrect. What's 2 plus 2? It is an incredibly claustrophobic hook. He quickly realizes, hey, he's got to play this computer's game just to prove he's conscious. This terrifying, disorienting awakening, that's the opening sequence of Andy Weir's novel Project Hail Mary. And today, we are unpacking this gripping, high-stakes opening act. What makes this whole thing so fascinating is that we, as the audience, are taken along on his exact cognitive journey. We only learn what he learns exactly when he learns it. We're going to use his deductive reasoning to solve the immediate mystery of his surroundings, and then piece together the giant, macro mystery of his past.
When his vision finally clears, what he sees is, well, it's pure horror. It's a stark, white, circular room. He's completely naked, lying in this weird, oval, hammock-like bed that's mounted straight to the wall. He's hooked up to dozens of medical tubes, feeding lines, waste lines, and he's covered in electrodes. Up above, these robotic arms hang from the ceiling, clearly acting as automated caretakers. And as he slowly gets his mobility back and literally rips his own tubes out, he makes a chilling discovery. There are 2 other beds in this room, and inside them, 2 mummified corpses. He is the sole survivor of some unknown mission, and he has a complete case of amnesia. He doesn't even know his own name.
Our amnesiac eventually manages to drag himself up a ladder into a connected laboratory. Right away, he notices his body feels incredibly heavy, and falling objects just look wrong, like they fall way too fast. Since he naturally knows how to operate complex lab equipment, he deduces, okay, I must be a scientist. So what does a scientist do? A DIY physics experiment. He grabs a dense plastic test tube, a brand new stopwatch, and a tape measure. He measures a table at exactly 91 centimeters. Then he pushes the tube off, times the drop, and repeats it 20 times to rule out human error. He gets an average fall time of 0.348 seconds. Using some basic kinematic equations he scribbles right on his arm, he calculates the acceleration of gravity in the room.
And that's when the terrifying reality of his situation becomes mathematically undeniable. Now, Earth's gravity is a constant 9.8 meters per second squared. But his math, it shows the room's gravity is 15 meters per second squared. He's experiencing roughly 1.5 times Earth's gravity. That's exactly why he feels so sluggish and heavy, and why a tiny fall off a ladder left him totally covered in bruises. Things are literally falling too fast. But you can't just magically turn up the gravity dial, right? So where on Earth is he? Well, the inescapable conclusion is he isn't on Earth at all.
But being a good scientist, he doesn't just jump to conclusions. He tests alternative hypotheses. Could he be inside some giant secret centrifuge back on Earth? To find out, he builds a makeshift pendulum out of nylon thread and that tape measure. The period of a pendulum's swing relies on exactly 2 things, the length of the string and gravity. He hangs it from the ceiling, starts his stopwatch, and counts exactly 346 cycles over 10 minutes. Then, he drops down to the lower room, a distance of 4.5 meters, and does the whole thing again. The result? Exactly 346 cycles. Now, here's why that is absolutely crucial. The fact that the swing didn't change completely wrecks the centrifuge theory. If he were in a spinning centrifuge, the centripetal force, the fake gravity, would be measurably stronger the further away from the center he went. By furiously scribbling math all over the walls, he calculates that to have 0 measurable difference across a 4.5-meter drop, a space centrifuge would need a radius of 1,280 meters. That is nearly a mile wide. There is no way humanity has ever built anything even close to that size in space. So if the gravity isn't coming from a massive planet, and it isn't coming from a giant centrifuge, there is literally only one other way to create a constant directional force of 1.5 Gs in space. Linear acceleration. Our guy suddenly realizes he is on a spaceship, and it is accelerating forward at a massive, continuous rate, basically pinning him to the floor the same way you get pressed back into your seat when you floor it in a fast sports car.
Part 1. The Petrova Problem. Recovering Memories of a Looming Apocalypse.
Right as he pieces together his physical reality, seeing a streak of his own blood triggers this massive, vivid flashback. He remembers reading a frantic email sent to an astronomy listserv by a Russian scientist named Dr. Irina Petrova. She was out there looking for nebula emissions, but instead she found this bizarre anomaly right in our own solar system. It was a faint, glowing line emitting solely at a 25.984 micron infrared wavelength. And the shape of it was even crazier. It arched 37 million kilometers straight up from the sun's north pole, then angled sharply downward, widening into this massive funnel pointing straight at Venus. Here's the kicker, though. Venus doesn't even have a magnetic field. There was absolutely no physical reason for particles to arc toward it like that. Then, another memory drops into place. A really tense dinner with a friend from the Department of Energy. She showed him data collected from a Japanese solar probe called Amaterasu. And this data? It proved the sun's energy output was actually decreasing. Now, at first, it was just a tiny 0.01% drop. But the true horror of the situation was that the loss was exponential. The probe confirmed that whatever this Petrova line was, it was actively stealing energy from the sun. In just 9 years, solar output would drop by a full percent. In 20 years, 5%.
Now, you can't just drop a star's output by a full percentage point and expect things to be okay. For Earth, this meant an immediate deep freeze. We're talking an instant ice age. Global crop failures, the total collapse of the biosphere, and mass starvation for the entire human race. This wasn't some distant, theoretical, maybe in a million years threat. It was an extinction-level event, and it was happening right now. Faced with absolute, literal annihilation, humanity actually did something unprecedented. We united. Every nation on Earth pooled unlimited resources to fund Project ArcLight. Normally, an interplanetary probe takes a solid decade just to plan and build. ArcLight, built and launched in under a year. Its sole mission was to fly to Venus, which is where the Petrova line was at its widest, orbit the planet, scoop up whatever this mysterious material was, and analyze it in a built-in laboratory.
Our amnesiac remembers sitting there watching the live feed from the Jet Propulsion Laboratory when the ArcLight data finally came through. They magnified the samples 10,000 times and found these tiny 10-micron black dots, but they definitely weren't space dust. As the whole control room watched in stunned silence, the dots began to deform, shift, and literally move around independently with zero external magnetic or static forces acting on them. So the terrifying conclusion was this. The Petrova line wasn't a weird energy beam, and it wasn't space weather. It was life. Humanity had just discovered extraterrestrial life, and it turned out to be a microscopic plague that was quite literally eating the sun.
Part 2. The science teacher. The amnesiac's true identity is finally revealed.
These doomsday memories finally break the dam in his mind. He suddenly remembers his apartment, his microwave dinners, and most importantly, his own name, Ryland Grace. And the contrast of his life is just staggering. In the past, he wasn't some elite astronaut or a hotshot fearless test pilot. He was a delightfully enthusiastic junior high school science teacher. He absolutely loved his job. He rewarded smart answers by throwing beanbags to his kids. He kept a jar of spaghetti and formaldehyde on his desk just to gross out his students. He was just a happy, ordinary guy. Yet somehow, this middle school teacher is now the sole, surviving, heavily muscled, terrified astronaut waking up from a coma on a spaceship in deep space.
So how on earth did that happen? Well, Ryland remembers getting cornered right after a class by Ava Stratt, this incredibly powerful operative for the UN's newly formed Petrova Task Force. Stratt didn't care about his teaching career. She cared about his past. Before he started teaching, Ryland actually had a doctorate in molecular biology. He had essentially been blacklisted from academia for publishing a wildly controversial paper claiming that the Goldilocks zone is a total myth and that alien life absolutely does not require liquid water to evolve. At the time, he was laughed right out of the scientific community. But with the sudden discovery of sun-eating microbes thriving in the freezing vacuum of space, suddenly, Ryland Grace was the only scientist on Earth who had been right all along.
The ship Ryland is currently flying on? It's literally designed to adapt. Once it stops accelerating, it's built to split in half and spin on cables, creating that centrifuge effect he calculated earlier, which allows for long-term survival in deep space. And just as the ship has to shift its configuration to survive, Ryland Grace has to adapt too.
He has to transform from a disgraced academic and a cozy science teacher into humanity's absolute final hope.
Which leaves us with one massive, thrilling question. How will a junior high science teacher, stranded light years from home with 2 dead crewmates, use his knowledge of biology and physics to stop an alien microbe from freezing Earth to death? Well, that is the unbelievable journey of Project Hail Mary. Thank you so much for joining me for this explainer. Keep asking those big questions, and I'll catch you on the next one.